The scenario comes up pretty often in the real world, so I wanted to make a quick video on it. We have two sites that need a tunnel set up between them. However, both of their local LAN subnets are overlapping. 192.168.1.0/24 is a common one, and the one that I'm going to be using in my lab today. I'm going to build that full solution from scratch. That's going to be our source NAT with IP pools, our destination NAT with VIPs, and then the correct phase 2 selector that we'll need in our VPN configuration. We're going to get it working, verified end-to-end, and then I'm going to intentionally break it with one of the slightly sneakier misconfigs that you'll encounter on FortiGates. That's going to be with our VIP objects. Showing our Eve topology here, we have two FortiGates, FortiGate 1 on the left, FortiGate 2 on the right. Our WAN interface is going to be 11.11.11.11/24 on FortiGate 1, 22.22.22.22/24 on FortiGate 2. As I mentioned, each of the local LAN subnets are going to be 192.168.1.0/24. In the center, we have a Cisco router acting as the ISP. The default route on each of the FortiGates is pointed to the router here, and we have it NATed outbound for live internet. So what the solution is going to be each site or each FortiGate a unique virtual subnet that only exists inside the tunnel itself. So in my case, FortiGate 1 is going to present itself as 110.110.1/24, and FortiGate 2 is going to be 220.220.1.1/24. All the translation is going to happen on the FortiGate themselves, so no host is going to need to be renumbered. I have nothing set up here besides just a default route and a default policy here. So the first thing we're going to go ahead and do on FortiGate 1 is create that IPsec tunnel. And we'll do something very basic, like FortiGate 2. For lab testing purposes, we're going to create everything with the most basic settings possible. Phase 2 is going to be the one thing we're going to want to pay attention to. So for our phase 2 selector, we're going to select for our local address. We're going to do our local virtual subnet, which will be 110.110.1.0/24, and our remote address will be 220.220.1.0/24. So we'll go ahead and create that. There's going to be a couple other things we want to do, but first we will go ahead and create that IP pool. The key setting here is that the type, we want to set it to fixed port range. So what that's going to do is create a deterministic one-to-one mapping. So 192.168.1.10 is going to always translate to 110.110.1.10, sort of in a sequential manner. The predictability of this is basically what makes reverse DNAT possible. So FortiGate 2 knows exactly which real host maps to which virtual address. IP pool is created. We're going to go ahead and create our VIP now, which will be our DNAT. Key setting on the VIP is going to be binding the VIP itself to a specific interface. So in our case, we're going to use our IPsec interface. Now we're going to go ahead and create the address objects that we need. So we'll just do 1 for FortiGate 2 remote VNet. So this, of course, is going to be 220.220.1.0/24. All right. So that's all done here. We'll go ahead and create our routes as the last step. Destination will be our FortiGate 2's virtual remote subnet. And we are also going to want to create a black hole route for this. Going ahead and replicating the settings here on FortiGate 2, starting with the VPN tunnel itself. Again, for the selector settings, our local address will be our local virtual subnet. And then remote remote will be, of course, the remote virtual subnet. Tunnels created. Moving on to the IP pool, our source net. Making sure to select fixed port range as our type. Moving on to our VIP for our DNAT. Binding it to our IPsec interface. Creating our FortiGate 1 virtual subnet object. And then lastly, creating our routes. And then, of course, FortiGate being a firewall first, we're going to have to create inbound and outbound policy. So starting with FortiGate 1, we'll go ahead and create our outbound. So that will be our local LAN to FortiGate 2. Our LAN interface, outgoing interface, select IPsec. Our source, we're going to use our port 2 address, which again is our local LAN address. Destination, we are going to choose our remote virtual subnet. Service, we'll select set to all for testing. And our NAT settings, we are going to enable this and select use dynamic IP pool. For the IP pool, we're going to select the one that we created. Enable logging. And then we will create the matching inbound policy. For our source, we're going to select the remote virtual subnet. Our destination is going to be the VIP that we created. Service set to all. NAT disabled. Logging. All right, so now FortiGate 1 is done. We'll go ahead and again replicate the settings onto FortiGate 2. NAT settings, select our IP pool. All sessions. And as you see by the IPsec interface icon here, the tunnel is now coming up. Again, for our destination, we're going to select our VIP, service set to all, and NAT disabled. All right, so configurations are done. We're going to go ahead and go over to the IPsec monitor here to see that the tunnel is up on FortiGate 2. Same thing on FortiGate 1. All right, so now we'll be able to see both of the devices. PC1, I guess Linux box 1, again, is at FortiGate 1. And then PC2 or Linux box 2 is at FortiGate 2. So you see here, the IP addresses that we're receiving is 192.168.1.2 on Site 1, and then 192.168.1.34 at Site 2. So in theory, we'll be able to ping our virtual address of 220, oops, number lock, 220.1.34, which we are receiving pings and back. And then on Site 2, we should be able to ping our virtual address 110.110.1.2, which we are seeing traffic flowing both ways. On the FortiGate, we'll go ahead and look at sessions, which you can see that we are seeing those sessions come through and able to get through on both sides. So before we go ahead and break it, I just want to show that everything is up and working. So VPN IPsec tunnel summary. What you see, our IPsec tunnel is up. We'll check our phase 2 selectors, tunnel list name to, which is up as well. And we will make sure that we have the route. So with those few outputs, our baseline is verified, our tunnel's up, our selectors are correct. NAT is translating in both directions. Traffic's flowing from end to end. So now we can get into the tricky part, the misconfiguration part, and break it. So now I'll introduce the bad or misconfigured VIP. I am not going to reference this in any policy or anywhere else on the firewall itself. It has nothing to do with this tunnel. It'll look completely harmless, unreferenced, but watch what it does to traffic if it is simply created. So test. And for the external address, the interface setting here, the key is that it is set to any. So we could use really anything here, but for this example, we'll just use the incorrect VIP setting. All right, so that's created. And if we go back to our test devices and we try to ping each other again, traffic is completely broken. Tunnel is still going to be up. The routes haven't changed. No policies were changed. The VIP object that we created wasn't referenced anywhere, and it just killed the traffic. So this is one thing to look out for if you are troubleshooting and nothing is making sense. Check in your unreferenced or orphaned VIP objects that you have. We will run a quick live debug. So debug. That's true. All right, so as you see, we had the constant ping going, so traffic came in right away. So when that happens, the packet never even reaches our route lookup. So the reason this happens is by design, architectural. FortiGate evaluates the VIPs at ingress before any routing, before any policy lookup. A VIP is not a passive object like an address group or an address object. It's a live DNAT hook that is wired into the kernel itself. So the orphan VIP here has its external interface set to any, which means that it's active on every interface, which includes the LAN. So when PC1's traffic hits the LAN interface, the FortiGate DNAT hook fires, which decides the packet is destined for itself. And as you see, or I guess here, and as you see, it handles it with the local in handler, which drops it at the implicit deny. So another gotcha with this is that the local out path, like if you're pinging from the FortiGate itself, bypasses any VIP evaluation. So that's why in troubleshooting, if you ping from the FortiGate to a tunnel address, it would succeed even with this broken config. So obviously the way to get through this would be to delete that object. When you have many VIP objects, this can be more difficult. You can go to the CLI and do some searching via that. But as soon as the object is deleted, you'll see traffic is able to flow again. Again, there was no tunnel changes, no policy changes, just removing the unreferenced VIP. So in summary, there's about 5 things to remember. One is that the Phase 2 selector on the VPN configuration itself is going to be using our virtual subnets, which is shown here. On our IP pools, we're going to want to make sure to select our fixed port range so we can sequentially translate our address. For our VIP, we're going to want to make sure to never set our interface to any, and we're going to always want to make sure to select the specified interface. 4, on the inbound policy here, as the source, we are going to select our virtual subnet, our remote virtual subnet, and our VIP as the destination. And then lastly, on 5, if you're ever seeing that the traffic or debug flow is showing the local in handler, especially a drop on policy 0, I would always recommend to check your VIP configurations first. Anyways, thanks for watching. I hope this was helpful. Any questions, please reach out and let me know. I'd be more than happy to answer them. But yeah, thanks.